Hello everyone. In this video, we need to find what is the voltage across the capacitor. If I give this kind of input, here I am giving the input to the gates of the FETs. The top here is NMOS and bottom is PMOS. In general, this is not a CMOS inverter. In CMOS inverter, top will be PMOS and bottom will be NMOS. And NMOS VTH is equal to 1 volt and PMOS VTH is equal to minus 1 volt. Okay, so first I am giving the 5 volt here input, that means gate voltage. So if I give a 5 volt, if I assume capacitor is initially charged to 0 volt, so VGS will be given 5 volt. Okay, so if I give 5 volt, VGS here will be 5 volt, and the same way here this is some 5 volt. So if VGS is greater than VTH in NMOS, so NMOS is on. So here in the first case, so NMOS on and PMOS off, because here VTH is equal to minus 1 volt, here we have given 5 volt, so PMOS is off and NMOS is on. So when NMOS is on, we need to find what is the region of operation. Based on that region of operation, we can replace with NMOS with resistor or current source. Based on that replacement of NMOS, the capacitor will charge. So if I see what is the relation, what is the node voltage, VD, VS, all those things. This is the drain, this is the source, this is the gate. If I see VDS, VGS minus VTH, if I find the relation between these two, then I can say whether this is in linear or saturation. So what is the drain voltage? VD is 5 volt minus VS equal to 0 volt, because I have assumed capacitor voltage initially charged to 0 volt, and VGS equal to Vin equal to 5 volt minus VTH is equal to 1 volt. So you can see that here VDS is greater than VGS minus VTH, which results into saturation. Okay, so we can say that here NMOS is in saturation because this PMOS is in off, so that I can replace this with the open circuit. So if I redraw the circuit, this will look like this. So there is a current source and there is a capacitor, and this is VC and this is VCC. So here there is a current source. In saturation, I can draw current source current will be K into VGS minus VTH whole square. So this is the current of the NMOS during the saturation. Okay, yeah, I'm ignoring the channel length modulation here. So VGS minus VTH whole square. So here this is a constant current source. If I give a constant current to the capacitor, so capacitor will charge VC is equal to 1 by C integration of I into dt. So if I replace this one, this will be constant current source will be I into T divided by C. Okay, so this is the current voltage build up across the capacitor if I give a constant current. But here what's happening is IDS is equal to VGS minus VTH. But here what's happening is VS is increasing, so VGS term, but G gate voltage is fixed. So what's happening is VGS is reducing, so IDS is also reducing. Ideally, what it should have happened, if I give a constant current source, the VC should have capacitor should have charged linearly, but because here GS is reducing, so because VGS is reducing, IDS gets reduced. So here I is reducing, that means slope, here slope is I by C. The slope of the charging voltage is reducing, that means the capacitor will not voltage will not be straight linear, this will charge like this. So that means it will charge like this. So there is no um, straight line because the current is not constant. So what I can say is the capacitor will not will even though if I replace NMOS with a constant current source, the current is reducing as capacitor is charging, so that the slope of the output voltage, the voltage across the capacitor, will reduce. So this will look like this. Slope is reducing, it's not a straight line. Slope is reducing and it will charge till NMOS is on. You can say that when NMOS is off, NMOS is off when VGS is less than VTH. So if yes, VGS is less than VTH means VGS is less than VTH. Okay, so VG is fixed, so VG is 5 volt, minus we need to find VS, and VTH is equal to 1 volt. If I say VS is greater than 4 volt, then I can say that NMOS is off. So that at 4 volt, 4 volt, NMOS is off, and capacitor is charged to 4 volt, and NMOS is off. So the output voltage will stay at 4 volt. Okay, so this is during when I give a V input voltage to 5 volt. Now let's see what's happened when I give V input voltage to 0 volt. So let me erase a few things. So if I consider when Vn equal to 0, so when Vn equal to 0, so here Vg, G is equal to 0 volt. So VGS, so gate voltage is equal to 0 volt, minus Vs is equal to 4 volt. So VGS equal to minus 4 volt. That means in NMOS, if you see, VGS is less than VTH. So then this is on, or else I can say that VSG is greater than VTH, then NMOS is on. So what is mod VTH? So VTH is equal to 1 volt. So VSG is equal to 4 volt. So NMOS, PMOS is on. Sorry, here the PMOS. PMOS is on and NMOS is off. So how I'm telling NMOS is off? Because gate voltage is equal to 0 volt, and source voltage equal to 4 volt. So VGS equal to minus 4 volt. So to on NMOS, VGS should be greater than VTH. VTH is equal to 1 volt here. So I cannot say minus 4 volt is less than 1 volt. So NMOS is off here. Okay. So I can now I need to find if PMOS is on, what is the region of operation of the PMOS. I need to find that. So if I see what is the region of operation of PMOS, so in PMOS, VSG and VSD minus mod VTH. If I find the relation here, then I can say that what is the region of operation. So VS is equal to minus 4 volt, and G is equal to 0 volt, and VS, sorry, here it's not minus 4 volt, 4 volt, it's charged to 4 volt, and VS equal to 4 volt. Sorry. This is a source, and here this is a drain. I have sorry here. So this is source and this is a drain. So Vs equal to Vs is equal to 4 volt, and G is equal to 0 volt, and Vs here is equal to 4 volt, minus D equal to 0 volt, minus VTH is equal to mod VTH is equal to 1 volt. I can say 4 volt, and here is 3 volt. VSG is greater than VSD minus VTH. Then this is in saturation. So in PMOS, if VSG is greater than VSD minus mod VTH, then PMOS is in saturation. If VSG is less than VSD minus mod VTH, then the PMOS is in linear region. So here we got it is in saturation region. In saturation region, I can replace PMOS with a constant current source. The current is flowing from uh, source to drain here, and there is a capacitor here, and there is a VC. So there is a capacitor and there is a constant current source. So here also we can replace, because of the constant current source, we assume there is a current linearly, the voltage across the capacitor should generally, so the current is drawing here, so it should be voltage linearly decreasing. But what's happening if you carefully see here, because we are here also in um, PMOS VSD, that means source to drain current. So that means current flowing from source to drain. VSD current equal to some K into VSG minus mod VTH whole square. You can see ISD is not constant here because it is depending on source voltage. As source voltage is reducing, because if I the current is flowing from VS source to drain, VSG will reduce. In the same way, ISD will reduce. That means if I write capacitor voltage will be, if I give a constant current source, I into TV divided by C. So the slope of the capacitor voltage is reducing. That means the voltage across the capacitor is not linear. This will reduce. So this will be like this. Initially the slope will be high, and going it will reduce. So eventually the voltage, um, VC will determine when the PMOS will turn off. Let's see whether it will reach to 0 volt or some certain voltage. So when the PMOS will off, when VSG is greater than, so I can say that VGS is less than VTH. Okay, so VG is fixed voltage 0, minus S is equal to, I need to find, less than VTH is equal to minus 1 volt. When VS is less than 1 volt, okay, then this PMOS will turn off. That means here it will not reach to 0 volt. Here it will be, VC will discharge to 1 volt, so it will stay at 1 volt. So when capacitor voltage reaches to 1 volt, then PMOS is off, and the voltage will stay there only, because PMOS is also off and NMOS here also off.